I've been there many times. Dockerfiles mistakes. I have no idea how many containers and Docker images I have spent time debugging because of my Dockerfiles mistakes. So what are the most common ones? Are these really related to the base image or maybe lack of the user directive? One thing I know for sure, these mistakes are extremely common among DevOps, cloud engineers, and even the senior ones. So in this video, I will walk you through the most frequent Docker file mistakes I saw and why they happen, and more importantly, what consequences they lead to. And at the end of the video, you will be able to avoid things like, for example, leaking sensitive files into your images, or for example, shipping unnecessary build tools or dev dependencies, breaking Docker's layer caching and slowing every build, creating images that behaves differently across environments, having containers run as root without you even realizing it, suffering for inconsistent dependencies, producing images that are impossible to debug. So this video is also part of my longer series on Docker engineering, and today in this video I decided to focus on Docker images once again. So if you are interested in more of the videos in this series, you can check other videos. You probably know at this point that Docker builds images layer by layer. Every instruction you write, from, run, copy, and adds a new layer. Each of these layers can help or hurt your performance depending on how do you structure the layers. And once your image is built, it's immutable, and this immutability is what makes Docker so powerful. You can run exactly the same image anywhere and you'll get exactly the same environment every single time. Today, let's look at the most common Dockerfile mistakes and their real-world consequences. Docker is also included in the LPI DevOps Engineer Tools certification. Click the link in the description to get 5% discount on the exam. Now let's come back to our training. The first mistake, using an overlay large base image. Our Docker files often begins with something like from Ubuntu latest. It looks just fine. It works. But this one line alone adds hundreds of megabyte unnecessary package and utilities never used in the production. If you start with the huge base image, you will end up with the huge container. It's really that simple. If you want to learn more about selecting base image, you can also see my following tutorial here. But as a consequence, you will end up with the slow dependencies, bloated image, and lot of unnecessary packages that only expand the attack surface. And that will happen if you use the wrong base image for your deployments. Second mistake, installing everything, well, just in case. Developers often write commands like, for example, run, apt-get update, or for example, apt-get install, curl, git, vi, Python, and dev build essentials. But your application doesn't really need half of these tools at your runtime, especially not in the production. You want your containers to be really minimal. As a consequence of installing too much of a software into your application, we might end up with a lot of vulnerabilities, more dependencies to maintain, and slower builds, and of course the image size that just keeps growing. So the rule of thumb here is that most of the time, tools like curl, wget, vim, git, or even build essentials are installed out of habit, not necessity. So yes, of course they are useful during the debugging or development, but your production container has no reason or to even open Vim, clone a Git repo, or download files from the internet. Keep your software inside the container really as minimum as you can. Third mistake, not using the multi-stage builds. We already discussed multi-stage builds earlier on this channel, so I will just be very brief here. When you compile code in the same image you plan to ship, you will end up dragging a lot of unnecessary baggage into your production. I'm talking about compilers, build tools, temporary artifacts, package managers, or header files. Basically, your entire development toolbox. But your production containers only need a final compiled output, nothing else. And as a consequence of not using the multi-stage builds, we have huge image, potential security risk, slower startup times, and fragile production environment that contains far more than it should. Multi-stage builds really solves all of this beautifully. They let you build your application in one stage using all of the tools you need and then copy that into the one final stage into clean minimal runtime image. And that means that your production image contains exactly what you need to run and nothing more. Fourth mistake, running containers as a root. Well, this is one of my favorite ones. This is of course one of the mistakes that almost everyone makes when they start to work with Docker. Not because they want, but because Docker makes it default. So if you don't explicitly specify a user, your container runs as a root inside the image. And at first it feels, well, pretty convenient because everything works, file permissions never complain, you can read and write anything and nothing seems to be really wrong. But the reality is very different. Running as a root inside a container is one of the biggest security risks you can introduce in your application. Even though containers feels isolated, the root user inside the container is still the root user. And if there's a vulnerability in your application, your framework or your OS layer, or even just a misconfigured environment, the root level access becomes extremely dangerous. And as a consequence, even a single exploit or remote code execution vulnerability can give an attacker full control over the container, and in some cases even let them escape the container boundaries. And this is absolutely not theoretical at all. Real world attackers have happened this way many times. Fifth mistake, hard coding latest or pinning everything too strictly. So using a tag like from node latest might look, well, pretty convenient, but in reality it introduces complete randomness into your builds. Latest is a moving target. Today it could be node 22, but tomorrow it will be node 23. And this means that your Docker file might slightly start behave differently tomorrow than it does today. So even if you didn't change a single line of code, your environment must still change because the latest tag will represent a different software version. And debugging this kind of thing is really not fun. But the opposite extreme is also a trap. Pinning everything into the micro version, for example, node 18.12.3, really locks your application into the image that will eventually go stale or outdated, unpatched, vulnerable, and old. You are basically freezing your entire runtime forever, which means no security updates, no bug fixes, no compatibility improvements unless you remember to manually maintain it. Both extremes really create the problems here. As a consequence of using the latest tag, it creates inconsistent environment, unexpected breakages, security risk from the outdated runtimes, and builds behave differently across machines and CI pipelines. What to do instead? A good approach is to pin the major version and let the updates float automatically. Like for example, from node 22 slim, or if you prepare more stable, from node 22.1 slim. So this will give you a stable foundation when you'll be receiving a security patches. Why all these things even matter, okay? So actually, each mistake might seem pretty small, but their consequences add up pretty quickly. So let's break down on what do they lead to in the real world scenarios. For example, slow and inefficient CI/CD pipeline, huge images that take forever to pull, security risk from unnecessary packages, containers that behave differently across the environment, runtime that crashes by the poor build structure, and of course difficulty in debugging because the container contains too much stuff. What next is that, for example, accidental leakage of the secrets, inconsistent dependencies, production issues that you would never seen coming. Docker really looks simple, but the way you structure your Docker file has a massive long-term impact. What is the key takeaway here? To put it simply, building good Docker file is not about writing more lines. It's about writing the right lines in the right order with the right intention. So once you understand the common mistakes and the consequences, creating a clean, fast, secure Docker image becomes much easier. Thank you very much for watching, and remember to subscribe. Thanks.